Okay, this section just still continues with finding roots, just kind of adding on a little bit to what we've already been talking about. All right, first thing you're asked here is for you to state the number of complex roots. Of course, this goes back to chapter 4 when you were first introduced to imaginary numbers. When you're referring to the word complex numbers or complex roots, that includes everything, whether it's real or whether it's imaginary. So, and I've already kind of referenced this on some other problems. When you want to know how many complex their roots are when you're talking about a polynomial equation, then all you have to do is simply just look at your largest exponent, in this case being a 4. So that's going to mean that your number of complex roots is going to be 4. Now, it could be that they're all 4 imaginary. It could be all 4 are real. It could be 2 are imaginary, 2 are real. There's different combinations that you can have. All right, next question is, well, what about the possible number of just real roots? Okay, going back to just the previous section, we had talked about the imaginary roots and the irrational roots being in conjugate pairs, okay? So you've got to keep in mind that those types of answers have to happen in twos because they have to happen in pairs, okay? So how many of them might be real? Well, all 4 of them, remember I'd already stated, all 4 of them could be real. But if I had, say, some that were imaginary, because they have to happen in twos, it could be that I only have 2 that are real, which would mean the other 2 would have to be imaginary, okay? But I also could have none that's real. Because if I have none that's real, then what that means is that I have 2 pairs of imaginaries. Like I would have, 2 that would be complex conjugates, and then I would have another 2 that would be complex conjugates. And all 4 of them would be imaginary in that situation. All right, then how many of them possibly might be rational roots? Okay, well, with rational roots, again, you could have all 4 of them being rational roots, but again, because you have not only the imaginary that happens in pairs, but you also have the irrational that can happen in pairs, then this is also going to be 4 or 2 or 0. And what you're doing is just simply subtracting 2 each time from the total amount, 4 being the total amount here, and you just subtract 2, and it's because they can happen in pairs. Okay, next example, doing the same thing. Okay, so first of all, complex, real, and the rational. Okay. Now on this one, it's written in ascending order. The order it's written in doesn't matter, just as long as you are locating your largest exponent, in this case being a 5. So your number of complex roots, you're guaranteed to have a total of 5 roots for this polynomial. Okay, it could be that all 5 of them are real, but if you start having any of them that are imaginary, they have to be in pairs, so it could be 5 or 3 or 1, okay? Now, you wouldn't go any further than either ending with a 1 or ending with a 0, because then you get into your negative numbers, and you're not going to have the negative amount of something. All right, same thing with your rational roots. It could be 5 or 3 or 1. So just like a while ago, I'm starting with my total, and I'm just simply subtracting 2 because of the concept of them being in pairs. Okay, so now actually finding some of these roots. Now, as you go through your homework, you'll have one section that says find all roots. You'll have another section that says find all zeros. But if you remember, the process that you go through to find roots or the process you go through to find zeros is all the same process. So I'm just going ahead and writing one set of instructions here. It could refer to either one of these. Okay, so based on what I've just told you, I know that this is going to have a total of 3 answers, 3 roots, 3 zeros, and it wants you to find all of them. The previous section, 5.5, we just concentrated, remember, on finding the ones that were rational in that list. So like in this case, we're looking for all 3 of them, whether they're rational or whether they're imaginary. Okay, so first of all, you're going to find your list like we had done before, like with the P and the Q. Okay, so P is going to refer to your constant term, which in this case is the -6. And you list all your factors of -6. So positive -1, positive -2, positive -3, positive -6. Okay, now Q is your leading coefficient, which in this case is going to be the understood +1 that you have here in front of x to the 3rd power. So that's just going to give us positive -1. So P over Q, you remember you got to take all of your P's and put those over 1. So 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Okay. Now, what you got to do is find one number in this list that's one of the actual zeros. So just like you did before, you're just going to have to start by substituting these numbers into the polynomial and finding out what makes it equal to 0. So like just start with +1, okay? So if you were to substitute in +1, I've actually already calculated these, but if you were to put in 1 and do 1 to the 3rd power plus 4 times 1 to the 2nd power plus 1 minus 6, you actually are going to get equal to 0, okay? So as soon as you find one, and there may be more, but what you got to do is plug them in and find just one that will make it equal to 0, okay? So now what you're going to do with this one is actually go back and do the synthetic division that we had learned earlier in chapter 5. So you're going to put the +1 over here in the little box. And then remember, you pull the numbers out of the polynomial. So this would be a 1, a 4, a 1, and a -6. Okay, you bring your 1 straight down. So 1 times 1 is 1. Add, you get 5. 1 times 5 is 5. Add, you get 6. 1 times 6 will give us 6, which does give us a remainder of 0. And that's because this was 0 here, okay? Now, if you wanted, you can plug it in like this until you find which one gives you 0, or you can do synthetic division every time until you find the one that gives you 0. But if you're doing this, once you find the value that causes your polynomial to equal 0, you do have to still do the synthetic division, because for the next step, I need these numbers that I have here across the bottom. So that's why you still have to do the synthetic division. Okay, so what you learned with the synthetic division is the polynomial that this represents is always going to be 1 degree less than what this polynomial is. So since this is a 3rd degree, I know this is going to be a 2nd degree. Okay, so from here, this means I would have 1x squared plus 5x plus 6. Okay, so now let's set this equal to 0, and now we're going to solve this quadratic. Now, once you get it to a quadratic, which means a 2nd power, you can factor. If you can't get it to factor, then it might be quadratic formula. It might be the square root property, like where you take square root of both sides, and I'm going to give you some examples of all those different situations. This one will actually factor for you, which will be the quickest. So, of course, x squared is x times x. Now, what you'll need to use here is actually 2 and 3, and you would need to add 2 and add 3 in order to get your 5. So you're going to get x is equal to -2 and x is equal to -3. So your roots or your zeros, again, whichever section you happen to be, working on, that would be the +1 that we found. And then, of course, the factoring here found the other two. So this is the answer that you're looking for.